Hi guys, welcome back for this module's recital. This week, we will add some prediction and forecasting tools in R to our current toolbox. Last module, we tried to understand the relationship between causes and consequences. This week, we're going to focus on using the knowledge built last week, in particular, our ability to build classification and regression models in order to make predictions on out-of-sample data, that is, data that the model has never seen before. As usual, we will review all the examples covered in class and explain how to use R to obtain the same outputs. Let's get started with the credit score example we saw last module. As we always do, let's set our directory to the folder where we have downloaded both the original credit scoring dataset that we explored in the last module and the new credit scoring dataset with the additional observation. For me, this is this folder, and I set it as my working directory. We then run this line in order to clean the memory of our current R session, and we then load our dataset with the read.table function and call the original dataset data old and the new dataset data new with the new additional observations that the model that we built last week has never seen before. Now, if you do not remember the dataset from last module, you should spend some time exploring it again with the str function and the summary function. Let's go over the data new dataset very quickly. If we run the str function, we see that there are 100 observations in this dataset and 10 variables in this dataset which are the same as those contained in the old dataset, namely the income variable, the rating variable, the cards variable, the age variable, the education variable, the gender variable, the student variable, the married variable, the ethnicity variable, and the balance variable. Let's run the summary function on data new. What can we learn on our variables in this dataset? First, we see that the minimum income is $10.73,000 US. The maximum is 182.73 in thousand US, and the average is 48.71 in thousands of US. Now, the rating variable has a minimum value of 112, a maximum value of 982, and an average value of 375.4. You should probably compare those numbers to the ones obtained on the original dataset. In any case, this gives us a good idea of the order of magnitude of the rating variable here. Now, like we did last module, let's build a linear regression model with the rating variable as our dependent variable and all the other variables as independent variables. Here we use the dot, and the data we use in order to build a model is our data old dataset, which is again the same dataset that we used in the last module. Let's run the line. Now that we have a model that we called linreg and that we assessed how it performed as we did in the previous module, we're ready to test the model on out-of-sample data. What we want is the model to give us predicted credit scores for the observations of our new dataset, the one that we call data new. Again, remember that this is data that the model has never seen before. In R, in order to obtain predictions made by the model on new data, we use the predict function. The first argument is the model that you want to use. For us, it's linreg. Then the new data argument is set equal to our new data, which in our case is data new as a dataset. Finally, our last argument allows us to choose the type of prediction we wish to make. Here, we set type equal to response in quotes in order to obtain the predicted credit scores. We then store the output in a new variable called pred credit score. Let's run the line. Now let's call the credit score variable in order to see its output. In order to do that, you can highlight the name of the variable and then press Command Enter on a Mac and Ctrl Enter on a PC. What the predict function has done is to predict a credit score for every one of 100 new observations. And it did so using the model developed on the in-sample data. Now let's see how the model performs using correlation between fitted and actual values on the data-O dataset. As we did in the previous model, we used the core function, the fitted values first, and the actual values second. We obtain a 98% correlation, more precisely 0.9867324. Now let's have a visual look at this result by using a plot which has the fitted values on the vertical axis and the actual values on the horizontal axis. Again, you see that the model does pretty well, although not as well on the lower values. Now that we know how the model does on in-sample data, let's check out how it does on out-of-sample data. Here, again, we use correlation. The first part here is our predictions, and then we have the actual values by typing data new $rating. We get an even stronger number of about 99%, more precisely 9880, more precisely 0.9880. Again, let's see the output visually by using a plot. We have less data point because we only have 100, but we see that the model does a pretty good job. And here again, we see that for lower values, it doesn't do as good of a job. What's interesting here is that if we had more observation, or in this case, more applicants for loans, for which we had values for all the explanatory variables, we could give them a credit score and assess whether or not it makes sense to grant them a loan from a business point of view. So that's it for this example, and I'll see you in the next video.